Welcome to In the Workshop, making a small but essential part for my traction engine. This is the finished part. Now I'm going to show how to make it. I fit a piece of steel bar into the chuck. This particular piece of steel bar has been partially machined because previously I used it as a mandrel for another job I was doing. If you watch my videos regularly, you will know that the process always starts by facing across the front of the work, centre drilling it, and then fitting a live centre in the tailstock. This is a very nice piece of steel. It's quite hard. I do think that it is silver steel, it's not mild steel. I will take the properties of this silver steel into consideration later on in the video. I thought I'd use this piece because it's more or less the diameter that I need to start with. But you could use a piece of mild steel. It needs to be something strong for the application that I need to make it for. For a distance of around 2.5 inches, I need to machine the diameter down to 7/16 of an inch. Yes, I think that will be fine, so now I can cut all the way down. This sequence is shortened and it's speeded up too. I'm using a new carbide tip on the tool and it's cutting beautifully. The oil seems to help as well, although it soon spins off. Industrial coolant, also known as soluble oil, is very useful, but I don't use it in my home workshop because I don't like the smell of it. That doesn't mean that everyone in their home workshop shouldn't use it, it's just my personal preference. Sometimes I smell bad enough without adding the aroma of soluble oil to the mix. After machining the diameter to 7/16 of an inch, I use some emery cloth and oil to polish it up a bit. One of the reasons that I decided to use this particular piece of steel for the job was that a while back I cut it about halfway through before I realised that I was cutting it the wrong length. I'm changing the lathe tool now for a round nose tool and it's stuck out of the tool holder way too far. This tool is designed to cut from the left, but I rotate the tool post so it will cut either way. It's quite a useful tool for profiling things. As you can hear at the moment, there is a chattering noise coming from the work. Using this round nose tool puts a lot of pressure on the work, which, as I just mentioned, is sawn half of the way through. That's why it's chattering. Provided that I take it easy and I'm not too heavy-handed with the round nose tool, it should be fine. I need to make 2 of these special parts. I'm only showing the making of one of them. And in this sequence I've offset the top slide. The lathe saddle is clamped in position and all of the movement you can see is me turning the handle at the end of the top slide. And just in case you may be wondering what I'm playing at doing this, well, I'm trying to turn a taper on the other end of the work. It took a while to get the angle right. It's very important that this part of the component looks good. And I started off by offsetting the top slide a very small amount. Then I stood back and looked at the job and thought, no, that's not right, it looks almost parallel. So I rotated the top slide a bit more, which is a very simple job. It's only clamped to the main slide with 2 Allen head grub screws. I'm still taking very light cuts because as the shaft gets thinner, it's going to start chattering even more. Depending on the size of lathe that you have, the sharpness of the tool, the speed of rotation, the type and thickness of the metal that you're machining can all contribute towards this chatter, and the end product is not a good finish. When I make the second one of these components, the finish will be better for a couple of reasons. The first reason is there will not be a saw cut half of the way through the bar, and the other reason is I won't be videoing it. When I record this video footage, I do have to leave the camera on automatic. And most of the time when I'm doing these jobs, I'm constantly looking at the viewfinder and then back to what I'm doing. And sometimes doing that causes the jobs to go wrong. I finished the taper turning, removed the component from the chuck, chopped it off on the bandsaw, and here, with the help of a pair of pliers because the part is very hot, I've turned it round in the chuck. I'm giving the taper a bit of a clean up using some emery cloth and oil, as shown before. Now I need to round the end. Normally I would use a V-tool like this to just chamfer the end, but in this case it's not a good idea because the part is very thin at the tapered end near the chuck, and the end of it is a long way, and I do not want to drill the end to mount a centre in there, because I think this would just spoil the appearance of the end product. I changed the tool for the normal small knife tool that I use most of the time and took very fine cuts, first across the front to face it, and then working manually around the corner. This involves turning the lathe hand wheels together to work as a team. There's a toy called an Etch-a-Sketch, so if you're not very good at this, buy an Etch-a-Sketch and practice. With this Etch-a-Sketch toy you draw pictures, and the pictures are drawn by using two knobs which move a pointer inside. I used to be obsessed with these when I was a kid, and it allowed me to develop, unknown to myself at the time, a good degree of manual dexterity and separation between left and right hands. Thankfully that's it for the turning in this episode. Now I can do something interesting with it. Over now to the bench vise. I've fitted the brass angles in the jaws to stop it marking the work, and here's the work fitted in the jaws. This is a heavy soft hammer. One end is made from copper on the right hand side, and on the left hand side it's made from hide. I'll be using the copper part for this job. Now I need a heat source, but this burner head is too big, so I changed to a smaller one, and here I'm heating up a specific part of the component, and that part is where the taper ends. I need to get this to a red heat. If I don't heat it up, it will snap off if I try and bend it, but once I get it to a red heat in this specific area, it bends very easily. Yes, I know the camera's not in the best place really, that's why I've speeded it up, so if you blink a lot whilst you watch this sequence, you will just see the part bending and not the hammer, and not my hand. How far to bend it, when to stop tapping, is entirely up to you. I stopped it at this angle, because I liked it that way. Here, as in the opening sequence, is the finished part. I've cleaned and polished it slightly after the heating operation. This is now what it looks like. The question is, what is it for? It's a fancy pin to connect my driving truck to the towing bracket on the traction engine. I need to now make another one to connect the driving truck to my water carrier. And that's it for this one. Stay safe and healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.